Let's go over science paper 2, which is 2016 GCE exam. The first question here, question 1, is short, says figure 1.1 shows an experiment which was carried out to measure the time interval of a simple pendulum. So you have got the bulb moving from point A to point B and then to C, like that. Okay. So the first question, the bulb was oscillating between A and C. So it was moving from the point A to the point C, as we have seen. So state the meaning of the term oscillation. So oscillation is, to oscillate is simply to swing forth and back, right? That is oscillation. So whatsoever way that you can put it, the movement of the bulb to and fro, all right? So that is oscillation. And then part B is saying if the pendulum took 0.2 seconds to swing from A to C, calculate the period. Now, you saw that A was here and then C was there. We've been told to move from here to there. It took, the time it took was 0.2 seconds. So meaning that the time it will take to move from C back to A will be the same to uh, 0.2 seconds. So what really is period? So period is the time taken for the bulb to go forward and then come back. That's the period. So what you are going to say is you are going to divide this movement. Okay, you have got the bulb is able to move from this point to this point, which is the end. So you can see that if it reaches this is half of the journey because it has to come back. If it comes back, then that is one oscillation. So just moving from this point to the end, that is the half oscillation. So we're going to say 1 over 2 cycles or oscillation is taking what time? They've told us 0.20 seconds. Because moving from point A to point C, that is half cycle. Now, what of one cycle? The time it takes to move for one cycle is what we call period, what will be the time t. Okay, so to find this t, we are going to multiply half multiplied by t, that will be half t, and that is going to be equal to 1 multiplied by 0.2, that is going to be 0.2 seconds. To remain with t, we are going to multiply everything by this 2 which is in the denominator, and therefore period is going to be 0.4 seconds. So this is how you do calculate the period of a pendulum. You can as well say period is given by the time which is moved divided by the number of oscillations. So the time, the time taken for the bulb to move is 0.20. How many oscillations did it take for it to move for this? So you see, it just moved from the point A to the point C, and that is half oscillation. So divided by 1 over 2. So dividing something by 1 over 2, you can also write as divided by 1 over 2 like that. And this is going to change into 0.2. We change to multiplication. The 2 goes on top, the 1 comes down. So this will still give us 0.4. So if you want, you can use the formula or you can use this relationship which is here. So that is how you're able to determine the period. So the period is simply the time taken for the bulb to move from point A to point C and then back to point A. So the movement from point A to point C is half a cycle. The movement of the ball from point C to point A back is another half cycle. So half cycle plus half cycle, that gives us one cycle. Okay, question C is saying using your answer to 1, determine the frequency of the bulb. Now, how do you find the frequency of the bulb? So frequency is simply 1 over period. That is how you determine the frequency. So frequency is defined as the number of cycles per second, right? The number of cycles per second. So this is going to be 1 over the period that you found is 0.4. So you just punch on the calculator 1 divided by 0.4, and that is going to give us 2.5. So this is going to be 2.5 hertz. That's a unit for frequency, hertz. So just that we are going to gain all those marks. Question 2. A lion of mass 200 kg is transferred from the moon to Earth. Acceleration of free fall on the moon is 1.67, while that on the Earth is 10 meters per second squared. State an instrument common used in the laboratory for measuring the amount of matter in a body. Now, what do we call the amount of matter in the body? That is the first thing that we need to. So, mass is the amount of matter in a body. So, what instrument do we use to measure mass? So, mass, we use a balance. So, it can either be a beam balance or an electronic balance or a triple beam balance. Okay, that is the amount of matter in a body. So, I can say we are going to use an electronic balance or a beam balance of those. Now, the second question is saying, state the mass of the 200 kg lion on Earth. Now, this lion has got 200 kg on the moon, and then it is transferred to the Earth. What will be the mass? So, mass does not change. If it has got 200 kg on the moon, it is also going to have 200 kg on the Earth because mass is constant, does not change. Calculate the weight of the lion on Earth. How do you calculate weight? Weight is given by mass multiplied by gravity. So the mass is 200 kg. Make sure that the mass that you are using is in kgs. If it is given in grams, convert to kg and then multiply by gravity. Now I want to calculate on the earth. The gravity on the earth is 10 meter per second squared. So this is going to give us 2000. Okay. If you multiply this kg and this meter per second squared, that will give us kg meter per second squared. So this unit called kg per meter kg meter per second squared is equal to a newton. So therefore weight is measured in newtons, 2000 newtons. That is going to be the answer for this question. Question 3. Let's see where it starts from. Alright, it starts from here. What is meant by the moment of a force about a pivot? Moment of a force about a pivot. So when you're talking about moment of a force, let's say you have got something like this. Okay, you have got a distance here. This is the distance d. Now you push this thing with a certain force. This force, you are pushing it at 90 degrees. Okay, shouldn't push like this. Push it at 90 degrees to the distance. So moment is the product of a force and the perpendicular distance. Okay, so you say product of force and perpendicular distance. The meaning of perpendicular is that the distance and the force, they are making 90 degrees to each other. So that is what we call moment. So therefore, if you multiply this force and the distance, that is going to give us moment because these two are making 90 degrees to each other. The next question is a moment of a force about a point depends on two factors. What are they? So the moment of a force is going to depend on the force and the distance, as we are able to see from the formula. So if you increase the force, you are going to increase the moment. If you increase the distance, you're also going to increase the moment. So the moment of a force depends on the force and the distance. All right, let's consider this one. Figure 3.1 shows a uniform meter rule which is pivoted at the 200 centimeter mark here. Actually, this is at the 20 centimeter mark and balanced horizontally by an object of weight 3.15 newtons. So this is the object that gets to balance it at the 10 centimeter mark. Calculate the weight of the meter rule. Now, one thing that we need to know is that the weight of anything is concentrated on its middle. Okay. Now, they've told us from the question to say this is a what? A meter rule. What is a meter? A meter, that is 1 meter, is equal to 100 centimeters. So meaning that if you are starting from here, this is 0, this is going to be 100 centimeters. And the weight of a ruler is concentrated on its middle. This is the middle. So this is where we're going to find the weight of the ruler. Okay. To find the weight of the ruler using the principle of moments. The principle of moment says anti-clockwise moment is equal to clockwise moment. So if I get this force, I multiply with the distance from the pivot, it should be equal to this force multiplied by the distance from the pivot. So that is what we call the principle of moments. Okay. So that is the one we're going to use. So what are we going to do in this case? Let me put the weight here, W. So this is going to be, let me call this distance here as D1. And then this distance here as D2. So using the principle of moments, we're going to say, let me call this as F. So we're going to say F multiplied by D1 should be equal to W multiplied by D2. So F, that is a 3.15 multiplied by d1. This is moving from 10 to 20. What's the distance? 20 minus 10, that is 10 centimeters. Okay. This one is in newtons. That is going to be equal to W multiplied by D2. So this is moving from 20 to 50. What will be the distance? So that is going to be 50 multiplied by 20. That is going to give us 30. Remember, this is in centimeters. To remain with W, we are going to divide both sides by 30 centimeters. The centimeter and the centimeter is going to cancel out. So therefore W is going to be, even also the 0 here will cancel out with a 0. So all we have is 3.15 divided by 3. 3.15 divided by 3. That is going to give us 1.05. Remember, you have got a Newton that has remained. So the answer is going to be Newtons. So this is the weight of the ruler. If the question was saying find the mass of the ruler, weight is given by mass times gravity. So the weight we have found 1.05. That is going to be equal to mass. We know gravity, this is on Earth, so divided by 10. Okay, multiply by 10, I mean that's a gravity on the Earth. So we're going to divide both sides by 10. So therefore the mass would have been 0.105 kg. Right. So if they asked for the mass of the ruler, let's consider question 4. Figure 4.1 shows a stone of mass 2 kg which drops from the top of a cliff and takes 2 seconds to strike the ground. Acceleration of free fall is 10 meter per second squared. Remember, it takes 2 seconds to hit the ground. Okay, you have got also the height h here. Now, just something before you even answer this question, you need to know is that when the stone is on the top here, it has got potential energy. Potential energy is the energy that is possessed by an object that is not moving, an object that is ready to fall. So if I've got an object on the table here, this object can't fall, so it doesn't have potential energy. Something to have potential energy, it needs to be able to fall by itself, all right? So as this object starts falling, the potential energy is going to be converted into kinetic energy. When it reaches the middle of the motion, potential energy is going to be equal to kinetic energy. Meaning that if the potential energy on top was 50 uh, joules, on the middle, you are going to have 25 joules being potential energy and 25 joules being kinetic energy, such that when you add them, you still get 50. And then at the bottom, all the potential energy is converted into kinetic energy. So here you have got kinetic energy. Potential energy is 0. So kinetic energy is going to be 50 joules. Just like here, kinetic energy was 0 on top. So that is just something that you should be able to know when you're talking about these energies. Now the first question says, name the form of energy possessed by the stone before it falls. So before it falls, it has got potential energy that we've already said. So determine the height h of the cliff. Determine the height of the cliff. Now remember, we've already been told that this is the height h given, that the stone took 2 seconds to reach the bottom. Okay, and at the beginning, it has not yet fallen, meaning that the initial velocity it has is what? 0. So to determine the height, that it falls, we are going to use the equations of motion. We can, those equations which have got height, we can say 2gh is equal to v squared minus u squared, or we can say h is equal to ut plus half at squared. Now this is going to be g because it is free fall. So we can't use this equation because we don't know the final velocity here. We don't know. So we're going to use this one with time. So we're going to say height is equal to, where there is u, that's the initial velocity, is 0, multiplied by the time, which is 2 seconds, and then plus half, g is 10, and then time squared, that is 2 squared. So the height is going to give us 0 times 2 is 0, plus half, so it's going to be half in, let me just say half multiplied by 10, or 2 into 10. That is going to give us 5. And then 2 squared is 4. So therefore the height is going to be 20 meters. That is going to be it. The next question, calculate the kinetic energy of the stone when halfway fallen. Okay, the kinetic energy of the stone when halfway down. Now the first thing that I'm going to do, remember we already said when it is here it only has potential energy, right? So here it has got potential energy. So I'm first going to calculate the potential energy on top. How do we find potential energy? Potential energy is given by mass times gravity times height. So this is going to be the mass of the stone. Let's see the mass of the stone given. So the stone is 2 kg. So we're going to say 2, and then gravity we know that is 10. So make sure that the mass is in kg. If it was given in grams, convert to kg. And then the height we have calculated what? Calculated 20. And make sure that the height is in meters. Mean that the potential energy is going to be 2 times 10, which is 20. 20 times 20 is 400. Energy is measured in joules. So that's the energy on top. Now remember, want to calculate the kinetic energy of the stone halfway on the middle here. And we said that kinetic energy here is equal to potential energy. Okay, meaning that when you have got a potential energy you said is 50, here the potential energy on the middle is going to be half of that value. Okay, which is 25. So the potential energy is going to be equal to the kinetic energy. Therefore, the kinetic energy on the middle is going to be half of the potential energy that is on top. So that is going to be half of 400. And the answer is going to be 200 joules. Now the final question is saying, find the velocity of the stone as it strikes the ground. So what will be the velocity at this point? So what equation can we use? We can say V is equal to U plus GT. We can use any equation or those equations which I've used on top. So the final velocity is what we want. The initial velocity we said on the on top here it is 0. And then plus G is 10. Time is 2 seconds that it takes to hit the ground. So that is going to be, the velocity is going to be what? 20 meters per second. We could have also said 2gh is equal to v squared minus u squared. So this is going to be 2g is 10. The height we calculated as what? 20. That will be equal to the final velocity squared minus the initial velocity is 0. Okay, so 2 times 10 times 20, that will be 400. And that is going to be equal to v squared. So to remain with v, you square root both sides. Therefore, v is going to be square root of 400 is 20 meters per second squared. So that is how you are able to calculate that. Let's consider also question 5. Two metal plates A and B, one with shine surface and the other painted black, are heated to a temperature of 100. So we've got two, one is black, one is white, and they are heated to a temperature of 100 degrees Celsius. So the metal plates are then placed in the open air or insulating material and allowed to cool. The table below shows the results obtained with time. Okay, so this is the results which are obtained with time. So you can see at the beginning they are both at 100 degrees. After 30 seconds, one is at 92, one is at 85. After 65, one is at 87. So you are saying that this one is losing temperature much faster. After 150 seconds, this one is at 60 degrees, this one is at 79 degrees. Now, when you look at surfaces, for a dark surface and a shine surface, dark surfaces are good absorbers of heat. Okay, and then shine surfaces are poor absorbers of heat. So because these they are poor in absorbing heat, they are also poor absorbers are also poor reflectors of heat. Okay, that is what we need to know. Poor absorbers are also poor reflectors of heat. Now the question is, which releases heat faster? Is it a dark surface or a lighter surface? Okay, dark or lighter surface. That's the question. Which one is going to release heat faster? So, dark colored materials both absorb and emit heat more readily. Okay, meaning that this one is going to absorb heat fast and also release it very fast. In other words, it's going to cool very fast. Okay, and then this one which is very difficult to absorb, when it absorbs heat, it is very difficult for heat for the object to release that heat. That is why when you are putting on a white shirt and it is hot, you are going to feel like very very hot. Okay, when you absorb the heat. Why? Because the heat is very difficult to be reflected, to be released. In other words, it will be bouncing back. That's the meaning. It will be bouncing back to you. But for someone who is putting on a dark shirt, you might not be able to get the heat very fast. Okay, I mean, you are going to get the heat very fast because it's a good absorber. But even if it's a good absorber, the heat is going to be released very fast. The reason as to why they don't advise you for you to wear white colored clothes when it is hot, I mean black colored clothes when it is hot, is because they are going to absorb heat very fast. But they also release heat very fast. That's what we need to know. So from here we can determine that this one which is releasing the heat very fast is dark, because dark colored clothes or plates are good absorbers and good emitters or reflectors. I hope that explanation is clear. So, by what process of heat transfer are the metal plates losing heat to the surrounding? So, we have got three processes of heat transfer: convection, conduction, and radiation. These are releasing heat by radiation. Okay, that is through a vacuum. Which metal plate is losing heat faster? So, which metal plate is losing much faster? It is definitely metal plate B, all right? That's the one which is losing heat much faster, because you can see the temperature is changing very fast. So it is B. State with reason which metal plate A or B has a shine surface. So which one has a shine surface? We are going to say A. What's the reason? Because it is a poor emitter. You see that it is emitting heat very slowly. So that is why we will say A is the one with a shine surface. Okay, so that is it for that question. Question 6. Figure 6.1 shows a vibrating tuning form Y in air. This one here. So this one is used to get to measure sound. State the nature of wave produced by the tuning fork. So state the nature of wave produced by the tuning fork. So if we are talking about the nature of waves, what are we trying to talk about? So we have got either longitudinal waves, okay, or transverse waves. Now when you are talking about sound, Is sound a transverse wave or a longitudinal wave? So transverse waves, these are waves which move like this, like water waves, and also can talk about, is it a spring? They go up and down. So the motion, the, these waves are going to be moving 90 degrees to the motion like that. And then you have got longitudinal waves which go like this. Okay, they go like this. Those are longitudinal waves. And so for longitudinal waves, they have got rarefactions and compressions. You are going to see at one point where there are a lot, and then at one point they split, and then at one point there are a lot, they split. So these where they are a lot, we call them compressions, and then here where there is a distance, we call them rarefactions. For example, a spring. Actually, a spring is a longitudinal wave. So same with sound, you can see that there is a go and a go and a come like that. So a spring, I mean sound. Now here we have got a vibration from a tuning fork. This a vibration from a tuning fork and also just from a spring. These are longitudinal waves because we have got rarefactions and compressions. We have got a go and a come. Unless when you see something like this is a longitudinal wave. Okay, so that is it. Question B. Show diagrammatically the regions created by the wave produced as it passes through the air. Show diagrammatically the regions created. So that's what we are saying. We're going to have this, and then we are going to have some spaces. Then we are going to have these which are closer. We are going to have those which are like that. We are going to have these which are closer. So we have got compressions and rarefactions, compressions, rarefactions. So that is what we have. These are rarefactions, and then these are compressions. Explain what happens to the speed of the wave in A if the rate of the vibration of Y increases but the length of the wave produced remains the same. So what is going to happen to the speed of the wave if the rate of vibration of Y increases? Like the vibrations are much higher. Okay, the vibrations are much faster, but the length of the wave produced remains the same. What is going to happen? So the speed is given actually by wavelength multiplied by frequency. That is how you find speed. So wavelength is the distance between two compressions or two rarefactions. So this is what we call wavelength. Frequency is how many waves are produced per second. So if you increase the number of vibrations, it means you have increased the number of waves per second. So meaning that the wavelength they've told us the length is the same, meaning that the wavelength is the same. If it was 5, it is still 5. But because you have increased the vibrations, what have you done? You have increased the frequency. So if the frequency was 2, maybe it has now become 3. So you've seen that because of that, you are going to increase the speed of the wave. All right. So the speed of the wave is going to increase. Okay, that is because you've increased the number of waves produced per second. That is why the speed is going to increase. Let's consider question 7. Figure 7.1 shows a ray of light entering and leaving a glass block. So here we have a ray of light. Okay, so at the top here it gets to bounce like that. So this line we call it the normal, the line that we draw in dotted on the surface, we call it the normal. Same, this is the normal. We have got, this is the incident ray, this is the reflected ray. Okay, this is reflected. We have got reflection and refraction. Okay, so refraction has to do with refraction. The word I'm mentioning is refraction. This one has to do with the bending of light. So it goes like that, it passes the medium like that. But reflection has to do with the bouncing of light. It comes like this and then it goes like that. So this called the reflected ray. This is called the refracted ray. Now, if it goes into a block like this is what we are calling the reflected ray. And then this one which comes at the end, which comes out, we call it the emergent or the emergence ray. Okay. So let's see the questions now, which are down. For the first one, name the rays labeled A to D. I've actually talked about this already. So let's get to identify them. We can see A we've already labeled as the incident ray. That's the incident ray. Okay. And then D is a reflected ray. And then B, we said this is the what? This is the refracted ray. And then C is the emergence or emergent ray. It's emergent because it's coming out. That's the meaning. So that is it for this question. And then for B, on the diagram, indicate I and R for the angles of incident and refraction respectively. So you want to indicate the angle of incident and the angle of refraction on this diagram. So if you look at the incident ray, we are going to look at the angle of incidence is the angle that is made between the normal and the incident ray. So this is the angle of incident. The angle of refraction, okay, R, is the angle between the reflected ray and the normal. So this is R. We also have this angle here. This is the angle of refraction. This is the angle of reflection. And then this is the angle of refraction. Okay, so those are different angles. So we have labeled I and R. So R is the angle of refraction. So the one they wanted us to label is this one here, which is refraction, not reflection. So it's that one. And then see, for a certain piece of glass block, the angle of incidence I is found to be 25 degrees. The angle of refraction, which is R, was found to be 16 degrees. Using this information, calculate the refractive index. Calculate the refractive index. Now, how do you calculate the refractive index or the refractive index? How do you get to calculate it? So, refractive index, which is given by the symbol n, is actually given by sine uh, of the angle of reflection, that is sine I, over sine r. That is going to give us the angle of, the refractive index. Refractive index is given by sine I divided by sine r. So we've already been given the angle, so those we just get to substitute. Okay, just get to substitute those. So this is going to give us sine I, we've seen that is 25 degrees, divided by sine 16 degrees. Okay, so we'll just get to punch this on the calculator. Just get your calculator, you punch that. That is sine 25 divided by sine 16. So this is given me 1.533. This is the refractive index, which we can just give as 1.5. That's the answer for this question. Okay.